Hello and very good day. I am Sef Sabr Abbas, metric number A19EC4057, with the project of Android malware detection in Android malware detection using deep neural network. With the project, it's a base research project that has been supervised by Dr. Bender Ali Arimi. And it will now will show the malware detection code that has been used to accomplish um, the project objectives and the implementations that has been done regarding the malware detection. The code is using a Python language, has been implemented, and without further ado, let's get started. Well, as you can see from the graph, it shows the code that has been already run, and giving the results for each graph. Um, the base code is, first of all, we have done a basic definition for the code, and in here the mal data, the PD read server, CSV will have shown the path of the data set in order to implement it on the experiment. As you can see, the malware data set that has been done. You can see the name, MD5 machine, and the minor linker version, the size of the code. These information are the base info of the data set that has been implemented, and the malware data shape, as we have described. And also in here you can see the malware data describing, it shows the mean, the standard deviation, the min length, that 25%, 50 and 75% of the data set, where it can, as you can see, the machine, this size of code that has been used. Later on will be shown the data set that has been implemented and the feature extraction. As you can see, this is a basic description for the data set that has been implemented. Moving secondly to the defining the legitimate and the malware to differentiate between them, whereas as we mentioned, it gave a 41,323 sample that are legitimate data, and 96,724 samples that are considered as a malware samples, with the features of 56 for both legitimate and malware. Uh, Moving below is showing the figure that given x-axis and the y-axis. The x-axis is showing a measure between 0 and 1 that are considered the most important measurement, where 1 is considered as the legitimate um, uh, samples, and the 0 is considered as the malware samples. Moving forward to the false positive. Okay, this is the false positive implementation that has been calculated regarding the malware detection in Android devices. The code base has been developed using the Python language, where as you can see, we have implemented the base code for the base equation for calculating the false positive rate, with a false positive of 20 and a true negative of 480 data set. Um, and also, moving forward to the false negative, we'll have in here up in the upper, we have calculated the false positive. Moving secondly to the false negative rate, where it showed a result of 0.0958 percent regarding the false negative rate. Whereas you can see the implementation of the equation implementation for the code, and also the FNR that has been implemented calculating the false negative, the functions for the false negative rate. And yes, we have also implemented the for the true positive rate. As you can see, the TPR, the equation of the false positive rate, that has been implemented with a true positive of 330 and a false negative of 35. That occurred with a result of 9% that has been mentioned in the slide presentation. Uh, Moving to the recall, which is, as you can see, it gave a result of 90% or 0.90%, with a true positive data of 330 and the false negative of 35. As you can see in here, this is a code implementation for removing, or yes, for removing the unnecessary data set. For example, in here we have decided to move the MD5 from the data set, and as you can see, the command result, the name and MD5 variable has been removed successfully. This is a basic code implementation. And as you can see, moving forward, the sklearn library that has been implemented, the tested size 0.3, 0.3, meaning that 30% of the data will be tested, will be, yes, will be present, and the rest of 70% will be trained or training data set. As you can see, this is the train shape in here, and also a max depth of 2 and a random state of 0. Uh, in here you can see we have also implemented the confusion matrix, which the report has elaborated more in the implementations of the confusion matrix and how it can help in uh, implementing the confusion metrics. How can it help in monitoring the malware in the Android devices regarding its malicious behavior? And as you can see, the confusion matrix of class 1 and the class 0. And moving forward to the accuracy training, where it shows a 98% regarding the accuracy of the training for the X train implemented. And secondly is the prediction random model of a result of 98% point 2, where it shows a very high accurate result. And moving forward to the model evaluation, the model evaluation used the X test and also the Y test to the prediction. The equals to the prediction, which gave a result of 70% point 23. And lastly, we have the F1 score. These are the equations that has been implemented regarding the F1 score and the tested data set of a true positive of 80 and false positive of 20 and false negative of a 10. That gave a result of 84% point 21. And lastly is the model evaluation have been shown, and currently, and the lastly is been shown the create of the train model, make a prediction of the dataset, and the model evaluation, where if y equal or higher than 0, then it's 1, if less, then it's 0. And as you can see at the last, we can see the confusion matrix result regarding the detection. And for the code base implementation, that is all. Thank you very much. I am Saif Sabr Abbas, metric number A19EC4057, with the project that has been supervised by Dr. Bender Ali Rimi. Thank you very much.